Today's lesson is a review of decimal operations. Decimal operations being adding, subtracting, multiplying, and dividing with decimals. What you're going to have in your notebook is similar to the regular operations review template that we have. I believe it's from lesson number 1. Wow, we're already on lesson 16. So this template, though, is going to be double folded. So the first time you open up your template, you should have what looks like addition, subtraction, multiplication, division, titles on the inside of your template with all the symbols and everything like that. However, if you open up your template one more level, so to speak, you'll then see the problems inside your template that we're going to work on today. So I'm going to kind of flip my notebook as I go, and I suggest you do the same. Let's start out with the multiplication problem. Multiplying decimals includes multiplying like you would normally multiply a problem, but accounting for the decimal places. So let's solve this problem here. 2 times 8 is 16. 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0. Bring down a 0. Because I have a 0 here, every time I multiply by 0, it's going to equal 0, so I'm going to skip that step. And my solution is going to be 0, 1, 6. However, I have 1, 2, and 1, 2, 3 decimal places in my factors. So I need to count all those decimal places up and insert them into my solution. So I have 1, 2, and then I'm going to have 1, 2, 3, which gives me a final solution of, this is the tenths place, hundredths place, thousands place, 10,000s, 100,000s. So I have 1,600 thousandths. That is my solution. I'm just going to gather my information here. And go ahead and rotate on to my next problem, which in this case will be the division. Division problem is similar to multiplication because you do it in the same algorithm that you would do standard whole number division. But first, you have to account for the decimal points. So in my problem, the first thing I'm going to do is shift the decimal point of my divisor over so that I have a divisor which is a whole number. However many places I shift the decimal in my divisor, I have to also shift it in the dividend. So I need to insert my decimal point there. I'm going to take that point and put it up in my quotient right away so I don't forget that that's where it's supposed to go. Now I just divide. 21 goes into 46 twice. 2 times 21 is 42. I do my subtraction. 46 minus 42 is 4. Bring down the next number, which is 5, and divide again. 21 goes into 45 twice. It's 42. Subtract. Bring down my 8. One more time. 21 goes into 38 once. 1 times 21 is 21. I do my subtraction, so I have 17 left over. I can continue this by adding a decimal and say how many times does 21 go into 170. But I certainly do not have to. I just have to decide whether this decimal is going to repeat or terminate. I believe this decimal is going to go on for quite some time. So I'm going to round. 21 goes into 170 about 8 times. And so when I round my solution, I'm going to round from my tenths place and say that my final answer is 22.2, or 22 and 2/10. to rotate my template one more time so that I may work on my addition problem. Adding decimals is very simple because we just add the way we normally add whole numbers. However, we have to be sure that the decimals are lined up. We have to account for all the place values. So as long as my decimals are in the same place, we won't have a problem. If you are missing any digits, for example, above my 8, I do not have a digit here, and I need one, I just insert a 0. This won't change the value of my equation, so it's totally okay to do that. Now I'm going to add 0 plus 8 is 8, 6 plus 1 is 7, bring down my decimal, 3 plus 2 is 5, 1 plus 4 is 5, and I have a final answer of 55 and 78 hundredths. For the very last time, I'm going to rotate my template so that I can solve my subtraction problem. Once again, similarly to the addition, subtraction is very straightforward as long as your decimal points are lined up. So 4 minus 7 is impossible, so I need to borrow from my 6. 14 minus 7 is 7. 5 minus 8 is impossible, I borrow from my 8. 15 minus 8 is 7. Bring down my decimal point. 7 minus 8 is impossible, I borrow from my 3. 17 minus 8 is 9. 2 minus 0 is 2. So my final answer is 29 and 77 hundredths. You have 4 proof problems to complete, 1 of each operation. So just be sure that you're being thorough and patient and following all the appropriate rules for these problems.